Hey guys, Adam from iClimate and you're joining us in London's Canary Wharf. Today we're going to talk about chilled water fan coil units, how they work and why it's the top tier of air conditioning and HVAC and how it differs from conventional air conditioning. So let me show you.
It's dripping down the heat exchanger and you can hear it.
So what's a chilled water fan coil unit? Above my head, it looks like a conventional air conditioning unit, but what it is it doesn't use refrigerant. It actually uses chilled water provided by a central plant in a building, and it distributes the cooling throughout the rooms. There are a set of actuator valves which control the flow of the water and the cooling requirements to the unit, and it's all controlled by a BMS and thermostat to make sure it all hums along energy efficient. Let's give you some background about this job. We were called in because the client said to me, Adam, I've got a couple of apartments in a block in Canary Wharf. They're supplied with chilled water fan coil units. They weren't too happy about the service they were getting from the building services contractor through the building management. And he said, I've got water leaks left, right and centre. Can you come and take a look?
Right, you see the drops. There's one there, there's one from this union, but that drop could just be something at the top. That's definitely.
They've done something there, yeah? Because can you see there's a fitting stuck in the middle there, loose fitting.
Yeah.
Yeah. So you know, if they've changed the fitting and then it's leaking,
It's not from the fitting, it's from the cap, it's from the heat exchanger. Yeah, we can see there's a leak there. It's dripping down the heat exchanger and you can hear it. You can literally hear that leak.
We found out that the heat exchanger had been compromised and was leaking essentially. We deemed that unrepairable because we don't want to carry out repairs we cannot warranty, especially in a block of apartments like this. So we had to task to find the new fan coil unit. The old fan coil unit was manufactured by SEAT, which are not a UK manufacturer. If you've been within building services, you'll have heard of SEAT. They make lots of heat exchangers and cooling related products, but they are very hard to get hold of and technical support is near to non-existent here in the UK. We were tasked with finding a replacement fan coil unit that integrated into the existing services and also physically fitted within the bulkhead space. 6 weeks to manufacture this. This is the heat exchanger on this side, condensate tray, electrical box, cooling and heating bodies that we've got to do. It's a bit bigger than the old one and we've got lots of cutting to do in the ceiling to get the old one out. It's going to sit a bit further. Let's get cracking. And as you can see, we've cut a lot of the bulkhead away here. The old SEAT units, from people that know building services and chilled water, are quite compact units. They're 200 mm in height. They do not have such a big footprint, but a lot of the larger chilled water fan coil units have a larger footprint because they are designed and built to up-to-date regulations, which means noise, health and safety and efficiency. Chopping back the insulation to expose the pipework to get it disconnected. Put the units off, guys. Fan coil unit has been removed. We're going to get the new fan coil unit in place on Monday because there's quite a few other obstacles in the way. The fan coil is much bigger. This has all been disconnected because we had to get the fan coil unit off, and the isolation valves are all shut. Please note that anybody comes in here and puts the valves on, it's not under our liability at all. There's no way of capping these off either because we need specialist fittings. And as I mentioned, which need to be ordered for this type of stuff to be rerouted. Wait, hold this way. Go on the ladder if you need.
one's off the door.
Oh, my one's not.
Yeah, we're going to see. As long as we can level it. Yeah. So that's where it's going to go. That's still too... Then that's, you have to fix that back. What space?
Small piece here, space here.
For the unit?
Yeah.
The air coming...
Right, so we were tasked with finding a fan coil unit that matched the size, that fitted within the space, the same configuration. This unit is a 4-port unit, so 2 ports are utilised for the cooling loop, flow and return, and the other 2 ports are used for the heating loop, flow and return. Each loop is controlled with a set of valves or actuator heads which modulate the control and flow of the chilled water and the hot water. And the operation of those valves is determined by the fan coil unit controller and essentially the thermostat on the wall which the user adjusts and sets. So let's go through some of the key components with the chilled water fan coil unit. So we have a fan coil unit, which is the large box, which looks like a typical ducted air conditioning unit. On the side here is the electrical box, which within it has the Delta 5 fan coil unit controller. Here is the extended drip tray. From the drip tray above it, we have the connection points to the heat exchangers that are sitting within the fan coil unit. We have 4 sets of pipes, which you can see here. Our pipes we've rerouted to the back there. These 2 are cooling, flow and return, and the back 2 are heating, flow and return. Flow goes into the bottom, return comes back out. We have 2 valves, as I mentioned earlier. One is the cooling valve and one is the heating valve, controlling the flow when is required for whatever mode the client sets this in. These are Honeywell valves, and when this cooling valve is turned into cooling, you'll see through the cover there, the spindle will then drive the motor, the mechanical valve down and allow the correct amount of flow into the heat exchanger. The same principle will apply on this side with the heating valve. The red light means the unit is actually on, and then when you're driving the valves, these specific valves have a different set of LEDs which let you know whether they're driving down, driving up, or whether they have an error on seating the valve or finding their position. This is the most important bit that you homeowners and the end user will obviously interact with. This is the wall thermostat controller that we installed. We replaced the old Honeywell Star controller that was here. The older Star controllers actually had the fan coil unit control section in here with fan speeds on, off, and all the other things. This is an up-to-date LCD model and it integrates with the Delta fan coil unit controller. So you have a full range of temperature. At the bottom, you have the current temperature that's in the room. It auto adjusts the fan speed according to the load. It lets you know if there's occupants, we're measuring temperature within the space. And on the left-hand side, it's in cooling mode. It'll give you the mode at which the fan coil unit is in currently. On and off, very easy to use and very user-friendly. You can see all our cores here. So that and that's all we need for the controller. 1 and 2 is taped together. That's going to be my communication 1 and 2 from the fan coil, and 3 is going to be my 24 volt DC and 4 is going to be my ground, and I'm going to chop the rest of it off.
So we're looking at the Delta fan coil unit controller. Fan coil unit controller is a 230 volt supply, comes into the transformer, and a section of it is stepped down into 24 volts DC. So we have power supplies coming into the controller. You'll see the controller has a status comms symbol there. We have our cooling and heating valves set up on the output configurations here. We have fan speed set up mechanically from a potentiometer here, and then the unit will adjust this according to the return thermostat and the actuator positioning. We have thermistors here, supply and return configured, and then we have our thermostat delta connection here. This side of the fan coil unit is very key. We configure this when we set up new fan coil units on site according to the type of interface or what we're doing. So if you have a BMS, you want BACnet, you want TCP/IP, or you want Ethernet, we will configure the fan coil units and assign it with an IP on the controller. So then when it comes to site commissioning on a large project, it goes smooth as possible. One of the obstacles that we had on this job that we encountered was the old fan coil unit was essentially driven by old 24 volt DC floating valves. This is for the controls people out there. It was simply supplying a 24 volts DC current to the valve and causing it to open and close and float within a position to allow for flow. This is modulating the flow in a crude manner. We've changed to up-to-date valves now, which are still 24 volt DC, but they are 0 to 10 volt configuration. So what that means is the voltage, as it's changed and increased and decreased, that has a direct correlation as to how the motor is driving the mechanical spindle and allowing for the opening of the flow. So there's a correlation of the 0 to 10 volt back to the fan coil unit to allow for a modulating, very efficient control. There's a whole range of actuators on the market. You get different types of actuators. The ones that we utilize, the Honeywell ones, they can be configured to work on an inverse way according to the voltage. So that when the voltage is applied, you can actually push the stem down, or when the voltage is reduced, you can push the stem down. You can inverse the operation. These valves are auto setting as well. So when you physically connect them, you connect the valve physically to the unit first and do not electrically connect it. And then it will find its valve position itself when it starts up. They have a reset configuration button on them, which they can recalibrate. When we commission the fan coil unit, we test all the valves to ensure that they are currently controlled by the controller correctly. This is the operation of the Delta controller. We have reduced the set point down to 17. The current room temperature is 25. And if you come up here, you can see on the left-hand side is our cooling actuator with our new pick valve installed here. The pick valve balances the flow also for the fan coil unit back. We've adjusted the flow rate on the pick valve mechanically to suit the flow rate of the heat exchanger. We found there was too much flow coming down here, and the lights indicating orange and that there show that that cooling valve is active. The bottom pipe is flow, lovely and chilled. Top pipe is coming back a bit warm. This is the heating valve and shows you the inside of the actuator. That valve, that means that position is fully closed. The valve has been given its signal. And when I adjust the heating, you will see that that actuator will move. Once now the unit is doing its cooling, the actuator valve is stepped down, stepped back up. We have decent airflow and water coming out. We just need to prove that we are getting flow through the flow meter on the cooling side, and we are 28 litres now on the cooling side. And if you look on the heating side, we have nothing because heating is off. We're going to quickly change this over to proof flow and leave this job finished. Let's test heating. We have 25 in the room currently. Turn the set point up to 28. We now look at our heating valve actuator there. You can see that is driving the valve with the flow through the pick valve. And then we're going to go verify that we have flow through here. This has been balanced, this pick valve, according to the flow rate of our fan coil unit. When you put on heating, our delta goes into red. 28 is the set point, 25.5. And we are seeing the heating valve on the right side. Actuator winding its way down through the pick valve allowing the return to open up. And we have lovely boiling hot water flow here into the fan coil unit. And we are heating on the air off. Let's go check the flow meter. And now we have flow on the hot side, and we are shut down the cooling actuator on the cooling side. So this has been configured and working properly. The 3 LEDs sitting here on the heating actuator will show that this is open a minimum of 75% under the control through the fan coil unit controller. And now we're going to turn the fan coil unit off and watch the actuator step itself back off, and then verify there's no heating flow through the PIC valves. The reason we're verifying the flow is because we had on site existing stiff PIC valves that possibly had debris inside, and we're just causing too much resistance for our set of actuators. And when you have that, the torque rating goes through the roof that is required to mechanically drive the spindle or release the stem, and then you can damage your actuators, which is the situation that we had, but we replaced them with another set of actuators we had. So let's go turn it off and verify flow and watch the valve close. The fan coil unit is off. Actuator is adjusting. You can tell by the sequence of the LEDs it's a Danfoss actuator. It's now closing the flow, and then we can go and verify that the hot water side flow is dropping. I'm going to quickly go over some of the issues that you encounter when you change fan coil units that are installed from maybe 15 to 20 years ago and you're trying to bring things up to date. Number one, spatial requirements. Old chilled water fan coil units, whether they're 4-port or 2-port, they are much smaller in footprint. The larger fan coil units, as I mentioned earlier, have a much larger footprint for the same given capacity. Reason being, the factories that make the units are adhering to noise ratings and energy efficiencies, which they can only control by making the actual chassis of the unit slightly larger. As you can imagine, installing a fan coil unit with a much larger footprint, not every bulkhead will allow for this. We were quite fortunate when we carried out the survey. I had a quick look. I could see no soil pipes in here. I could see some T&E cables, some lighting running. We did our measurements to ensure that the new fan coil unit would fit. But as you can see, it was still very tricky. We had to remove a lot of the face of the grill to actually get the unit in. Number two, unit heights. So the existing unit was smaller. The existing unit also sat higher. So we had to adjust the discharge plenum to make sure that the grill location, which remained fixed due to the ceiling height, lined up, and we were not affecting airflow in any negative way. It's all good getting things to fit, and it's all good getting things to work, but you have to maintain these things that you install. And these pieces of equipment need adjustment and regular servicing. So as you can imagine, with a larger fan coil unit, we had to take away a majority of the ceiling, and we have to come up with a way where we can provide access and get access to the filter so we can do the annual maintenance to ensure this unit works correctly. So we'll give you an idea of what's involved when you change a fan coil unit on a chilled water system in a large residential block. There's lots of things that you have to adhere to: the initial design temperatures, flow temperatures, the main central plant, the BMS on site, the method of control, spatial constraints, noise constraints, cutting into the fabric of the building safely, if there are any obstacles in the way, whether all the services that need to be diverted in accordance to building regulations, and also the thermostat control for the user to ensure that the comfort is maintained all year round. So I hope that gives you guys an idea that at iClimate, we don't just do split installations of air conditioning. You may have seen some of our previous videos. We are slowly touching on more and more of the commercial and industrial side that we do here at iClimate from our background. And we love looking at large industrial water chiller plant, air handlers, BMS systems and control systems as a part of our commercial HVAC service to London. I hope you found the video informative, and we look forward to helping you with any of your chilled water fan coil unit inquiries. Thank you.